discussing a few rules for the derivative. Now, since you're taking real analysis, if you have this function put in front of you, you could probably take the derivative pretty easily. Maybe it'd take 3 or 4 minutes, but that's not a lot of time. But now let's try plugging it in to this. So, let's see. And include that. So let's see. We get 1 over x plus h minus 3 squared sine of x squared plus 2xh plus h squared minus 1 over x minus 3 squared sine x squared over h. So where do we even start here? I mean, there's no formula for sine of something times another something times itself. There's no identity for sine of x squared. And in the same area, technically there's an identity for sine A minus sine B, but that's blocked by these two having different denominators. So what do? It's literally impossible to solve with this. So instead, we have to break it down using smaller rules that we can figure out from this base definition. So earlier we figured out the power rule, but I'll repeat the derivation again. So given that f of x is of the form x to the n being any real number, then f prime of x is equal to n x to the n minus 1. How do we know this? Well, let's take the raw definition. F of x plus h minus f of x divided by h. The limit as h approaches 0. And this should be one of the most intuitive definitions we've come across, because basically it's just like taking 2 points and making them ever and ever closer until the distance between them, so I'm technically magnifying them right now, the distance between them can be considered a straight line, which in practice is never, but essentially we're zooming in farther and farther and seeing where the slope of that secant line that goes through those 2 points approaches. So in other words, the limit of the secant line as these 2 points approach 1 point. So what's f of x plus h? In this case, it's x plus h to the n. Oh crap, I gotta add the limit. And then what's f of x? It's just x to the n divided by h. Now, by the binomial theorem, what's the expansion of x plus h to the n? Well, firstly, we have the terms x to the n plus nx and hx to the n minus 1 plus h squared x to the n minus 2 plus h cubed x to the n minus 3 plus dot 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 plus h to the n. Now, here's what you have to keep in mind. We're dividing everything by h at the end of the day. So eventually, this is going to look like 1 over h x to the n plus x to the n minus 1 plus h x to the n minus 2 plus h squared x to the n minus 3 plus dot 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 plus h to the n minus 1. And you must realize that as h approaches 0, all of these terms are going to go to 0 as well. But there's another catch. We have the binomial coefficients as well, which by the theorem, each term is just going to look like hk, x to the n minus k, n choose k. So in this case, we have n choose 0, which is obviously 0, n choose 1, and mathematically you can obviously calculate that to be equal to n, but physically think of it this way. We have a set of n objects. How many ways are there to choose exactly 1? That's right, just n. So that means we get n over here, and then all these other ones, this one is n factorial over n minus 2 factorial times 2 factorial, which is equal to n times n minus 1 over 2. But whatever these are, these don't really matter because they're all going to approach 0 anyway. Now I hear you saying, well, what about this term in the front? Well, here's the lucky thing. That gets canceled out by this, which means that at the end of the day, we have x to the n plus, x to the n plus n h x to the n minus 1 plus n squared minus n over 2 h squared x to the n minus 2 plus dot 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 minus x to the n all divided by 8. Now these two cancel out and we get nx to the n minus 1 plus n squared minus 2 or minus n over 2 h x to the n minus 2 plus dot 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 plus h to the n minus 1. And obviously, since we're taking the limit as h approaches 0, any term containing h, as we plug in chug, will also go to 0, meaning that our answer is just nx to the n minus 1, which, since it doesn't contain the variable h within it, is correct. All right, and also, by the way, note that in this problem, we're essentially treating x as a constant and h is the actual variable, because h is the thing that's approaching 0. All right, so now that we've done the power rule, let's get into the product rule. So the product rule states that given two functions f of x and g of x, their product, the derivative of their product, is equivalent to the derivative of f of x times g plus the derivative of g of x times f. So how do we prove this? Well, the key is all in one very nice factorization. So if we take f of x plus h and set it equal to g of x plus h minus g of x, and then we have plus g of x times f of x plus h minus f of x, what is this equal to at the end of the day? That is equal to f of x plus h times g of x plus h minus f of x g of x. And that's exactly what's going to be on the top of our derivative. So d dx f of x g of x, by definition, is going to be equal to the limit as h approaches 0 of that divided by h. And now, using that cool factorization we found, we split this up into two fractions. F of x plus h times g of x plus h minus g of x divided by h minus, plus g of x times f of x plus h minus f of x divided by h. And now you'll notice this right over here is equivalent to g prime of x. And similarly, you'll notice here, this is equivalent to f prime of x. So we have the limit as h approaches 0 of f of x plus h, g prime of x, plus g of x, f prime of x. And of course, since h is approaching 0, we just plug in chug and erase this away, which gives us our final answer. All right, so that's the product rule. Now, let's look into the chain rule. The chain rule is useful because it essentially says if we have f of g of x, which comes up when we have functions like sine squared x or e to the 2x squared, we have something like that, the derivative of this is equal to f prime of g of x. Essentially, we take this function, put it through g, and then put it through f prime times the derivative of g of x. So now this comes from a much simpler principle. So we take the limit as h approaches 0 of f of g of x plus h minus f of g of x divided by h. Now, let's think about something for just 1 second. This is equal to f of g of x plus h minus f of g of x, and let's ignore what the rest says. Let's pretend this is what we have right here. Doesn't this look similar to something? Like, we know that f of x plus h minus f of x divided by x plus h minus x is equal to f prime of x. So, wouldn't it be correct logic to state f of g of x plus h minus f of g of x divided by g of x plus h minus g of x is equal to f prime of g of x? So that's the operating principle. So we split this open, and then of course, to keep everything the same as it once was, we multiply this by g of x plus h minus g of x over h. But wait a second, we've coincidentally just created the exact definition of g prime of x, which means this is f prime of g of x, and this is g prime of x, which gives us f prime of g of x times g prime of x as our answer.